So, welcome to one of the most deceptively dangerous concepts in programming, and one of the concept that explains why Redis is blazing fast. Even if count plus plus looks like a one-line operation, right? But under the hood, it's actually three steps. So, ideal the value, final value of count. This would print as 4 lakh, but if I just run it, you will see that every time we are getting random number, different numbers. There is no guarantee. Hey everyone, welcome back to the channel. So by looking at the title and the thumbnail of the video, you must be thinking, अरे यार count plus plus तो हम कॉलेज से यूज करते आ रहे, लिखते आ रहे हैं. We used in assignments, we used in projects, we even production में डाल दिया इसको. आज तक issue नहीं है. We did not face any issue till today. Then why now people are talking about is कि count plus plus is not safe. How can this innocent little line be so unsafe? So welcome to one of the most deceptively dangerous concepts in programming, and one of the concept that explains why Redis is blazing fast. When we write count plus plus, it's simple and works beautifully in a single threaded system or single threaded program. That's why you have never seen it crash or misbehave till now, because most of the programs that you might have worked works in a single threaded environment. But when you enter multi-threading, when we think about multi-threading, all the issues start to occur. In a multi-threaded app, when two or more threads might access count at the same time, then we might land into this kind of problem where the count plus plus can misbehave, or it can produce unexpected results. Why and how? Let's say currently we have, let's say, count plus plus. Here we are doing, let's say count is currently 5, and we have two threads doing the count plus plus. Here we have two threads and they are doing the count plus plus because they're running this increment function. So here's what could happen. So thread A, the first thread reads count is equal to 5. Thread B will also read count is equal to 5 before A writes the updated value. Now thread A increments to 6 and writes it to the value, to the memory. Then thread B also increments its own 5 to 6 and writes it to the register or memory. So final result is count will be 6. But you did count plus plus twice, right? Here we have two threads are doing that increment function. So ideally the expected output should have been 7, but it is not the case. Now let's just look at this program. Let me just switch to this code. Now if you look at this program should ideally print 2000, right? But if you run it fewer times, it will start seeing numbers like 1984, 1956, even 1900, anything, random values will start to see. That's because count plus plus is not safe when multiple threads try to access and modify the count at the same time. Just verify this argument. What we'll do, we'll just run a program, okay, in our code locally. So what I've written a CPP code where we have 4 threads. I've not taken 1000 because with a smaller number, sometimes the thread, even before the second thread starts to execute, the first thread executes completely. That's why in order to simulate this environment of unsafe C count plus plus, I've taken a larger value of I, and we have 4 threads. Now if you just compile this program, and then we are joining all the threads, and this is how multi-threaded environment looks like. Now if we just compile this program and run it, ideally what we should expect, we are incrementing the variable 4 times here. So ideally the value should be what, 1 2 3 4 5, it's 1 lakh, right? So ideally the value, final value of count, this should print as 4 lakh. But if I just run it, you will see that every time we are getting random number, different numbers. There is no guarantee. Okay, why there is no guarantee? Because even before some other threads writes a particular value or particular updates to the register, some other thread might be accessing an old variable or old value and then writing it or overwriting to the memory. So that's why we see this inconsistent outputs. It's all due to inconsistent writes by multiple threads at the same time. So you see, we are getting all random outputs. We are not getting 4 lakh, not even closer, right? So the main thing is, even if count plus plus looks like a one line operation, right? Here we have just one line, count plus plus, but under the hood, it works. It's actually 3 steps. Okay. First, internally the count is assigned to a temporary variable. Then temp is incremented to temp plus 1. Then the temporary variable is written back to the original count variable. So this is why the inconsistent value comes into this picture. Now how do we fix this? If we have this issue, there must be some way to fix it also. So this is where the mutex come into picture. So if I just uncomment this line and clear it. I'll compile it again. So this standard mutex ensures that only one thread can touch the count at a given point of time. It's like putting a security guard. This mutex that you're putting, it's like putting a security guard around count plus plus. So thread A locks it. So thread A locks it, then updates it, increments it, then unlocks, then other threads start using that variable. Now if I just run this program, you will see that every time you will get the consistent count as 4 lakh. How many times you want to run, you run it, because now the operation is locked first by a particular thread before any other thread starts to execute the same process. Even better option is to use or declare the variable as atomic. So you just declare that variable using atomic. This makes the plus plus operation atomic and threads are by default without any need for locks. So it's faster, lighter, and perfect for small shared variables like counters. So this is another approach which you can think of if you are dealing with multiple threads in your program. So you know what's fascinating? This whole count plus plus issue helps actually why Redis is so fast. Redis handles millions of operations per second, but it never worries about thread safety. Do you know why? We're going to discuss about it in our next video. So let's keep it for the next video. All right. So is count plus plus always unsafe? The answer is no. If you're writing a single threaded CLI tool, let's say something tool or program that you're developing, it's single threaded, or your script you are using for personal use, or anything that runs a single thread, that's the final bottom line. If anything runs on the single thread, you can use this kind of increment. It is completely thread safe. Then go ahead and no problem. But the moment you start using threads, even for something as simple as updating a counter or handling HTTP request, you need to be careful. So the final bottom line is count plus plus is not atomic. It's 3 steps, not one, as we saw here. It's ideally 3 steps, not a one line operation. In a multi-threaded code, it can fail silently. So you can fix it with using a mutex or using the atomic declaration of variables. And remember, systems like Redis avoid this altogether by being single-threaded by nature and by design. So in detail, we'll discuss about why Redis is so fast and all the underlying internals about its architecture and all in detail. So hope you enjoyed this deep dive into a deceptively simple bug that you may encounter in the future. So if you have ever been bitten by this race condition, let me know in the comments. So if you like this video, let's drop a like. Let's target for 50 likes for this video. And please subscribe to my channel. I'm targeting to reach 3,600 subscribers by the end of this month. So keep supporting. And if you want more practical dev breakdowns and deep tech breakdowns like this, please consider sharing this channel with others and subscribe to my channel. All right. So thanks for watching this video, and I'll see you in the next one. Thank you.